Have you ever wondered why the ordinary computer that we use in our everyday life has become so fast in the last decade? Well, it has to do with its storage device, which used to be a hard drive. Now it's normally a solid-state drive, which is faster. But in order to understand how a solid-state drive works, firstly, we have to discuss about ferroelectricity. Well, ferroelectricity is a word which linguistically is formed by analogy with ferromagnetism. Everybody knows that if you put a piece of iron in a magnetic field, it becomes a magnet itself. Analogously, if you put ferroelectric material in an electric field, you apply a voltage on it, then it starts behaving like a battery itself. Why is it so? Because its molecules, they are called dipoles. They have two poles, two electric terminals, a plus and a minus, just like a teeny-weeny little battery, and they are normally disaligned, like randomly aligned. But when a voltage is applied to the material, which is a ceramic, then they do align with the direction of the field, and the material starts behaving like a big battery itself. Well, a solid-state memory inside the computer is built of a lot of such little ferroelectric ceramic pieces of material, which are polarized up or down, left or right. It depends on the construction. But in any case, the direction of the polarization dictates the logic value that it stores 0 or 1. My research focuses on porous ferroelectric materials. It may sound a little bit strange, because by inducing porosity, one is removing material from the bulk, and this means removing the batteries, little batteries in discussion. But the truth is that those pores concentrate the field, and even though they are the number of batteries is smaller, they are a little bit more powerful, and the effect can enhance. How am I doing this, you may ask? Is it complicated? Well, in principle it is, because the equations of electromagnetism that are used to compute such properties are differential equations. They are complicated. But in order to simplify my life, I use finite element method. I break the structure that I design on the computer into small pieces, finite elements, ideally of the size of such a battery. I do apply locally the equations of the electromagnetism. I compute properties, and then by using mathematical algorithms, I reunite the results into big numbers, into properties, effective properties, numbers that do describe the system as a whole. Well, this has led to a lot of enhancement and will lead to even better systems and better properties. Thank you so much.